arithmetic sequences. Now we're going to do some geometric sequences. So just a reminder, your 2.1, 2.2 quiz opens tomorrow. We will not have finished 2.2 until Friday. So sometimes I open it early in case you want to start working on it. Just know that there might be something on there. You try and do the whole thing tomorrow for whatever reason that you don't know, that you would have to just wait to go back and do that one. By Friday, you'll have learned everything, okay? And that you have a whole week. Guys, let's make a change this quarter and make sure we are not getting zeros on stuff, okay? I don't give you one day to do it. I give you a lot of time. And first quarter, I even extended dates a couple times to kind of help you, but I'm not going to keep doing that. You guys have to get organized with your what's due in this class, okay? All right, so geometric sequences. So sequences are an ordered set of numbers. Arithmetic was you were adding the same number left to right. With geometric, we're multiplying the same number left to right, okay? And instead of having a D, we have something called an R. So here's an example of a geometric sequence. I think you guys could look at this and tell that we're multiplying by 2 the whole way down. So multiplying by a constant number. So in this case, your common ratio, and I'll talk about why it's called that, is 2. We have a explicit formula, general formula, just like we did yesterday. We actually have 2 of them, just like we did yesterday. But unlike yesterday, we typically use this one the most, okay? I will talk about when this one is used when we get to our last example, which is a word problem. It's used a lot in word problems, and I'll explain that in a few minutes. But for the most part, the original one is the best one, and it's easier than the arithmetic one because if you remember the original problem that had the A's and the N's, not the G sub 0. Okay, let me say it like this. The one that uses A sub 1 instead of A sub 0. That one yesterday was fine to use, but remember you had to do the distributive property and combine like terms. There's a little bit more work in it. What's nice is with the geometric ones, we don't have to do any simplifying. We plug in the first number, the R, and that's it. We're done, okay? Now, that is called a common ratio because a ratio means a fraction or division, okay? It's just another word for fraction or divide. So just like yesterday, if you were looking at this and you couldn't tell what the R was, you can do a test, which is to divide in the reverse direction, so consecutive numbers. So just like yesterday, we would see 8 minus 4, 16 minus 8. Nope, they're not the same number. It's not arithmetic. Here, to test for an R, you could do 8 divided by 4, ratio, 16 divided by 8, and so on. And I would say 3 of them to determine if it's the same number. And of course, all of those equal 2. We didn't need to do the test to figure that out. I think we could look at that one and see it pretty easily, but that's how you would test it. We're multiplying to the left, dividing from the right. Okay? Just like yesterday, adding to the left, subtracting from the right. Opposite operations. Okay? Don't really worry about this formula. This one is wonderful. You're going to use this one a lot. The geometric mean. Think about what mean means. It's average. It's like if you want to find the average of 2 tests, you'd add them together, divide by 2. That's adding. But with geometric, you multiply them together and find the square root. So when you would use this is if you're given like a number, you're missing a number in the middle, and then you have another number. So you could multiply these 2 numbers together and divide by, and do the square root, and you would have the number in the middle. And we'll do one of those in the notes here in a minute, okay? Really, really simple. Okay, so let's get to our first questions. Determine whether they're geometric, so yes or no, just like yesterday. Find the R, and we're going to write the explicit formula, okay? So looking at this, I think this is one of those that you can look at and tell. You're multiplying by 2, by 2, by 2, right? So R is 2. And yes, this is geometric because I have 2 the whole way down. It's not changing numbers. This number is constant the whole way through. So let's just write the formula. So we can find any term, right, any one we want. We can find the third or the 33rd or the 103rd. First term is 3. R is 2 to the n minus 1. And that's it. You cannot simplify that any further. You cannot multiply the 3 and the 2 together. Okay? the 2 has something going on in its exponent, you would have to do that first. And since we don't know n, we can't do anything else. So these are really easy to plug in to create the formula. Okay. Let's test this one. If I do negative 9 divided by 3, does that equal 27 divided by negative 9? Does that equal negative 81 over 27? And this could be done in your calculator. I don't need to see this work. Okay. So I'm just finding consecutive terms, ratios, right to left. The order matters. Okay. And I get negative 3 the whole way down. So yes, this is geometric, and we have an R of negative 3, right? So writing the formula, super, super easy. A sub n equals the first term, which is 3, R, which is negative 3, to the n minus 1. Okay. A couple more of these. Can't tell. Let me do some testing. 5 over 1. Does that equal 9 over 5 and 13 over 9? Any 3. I mean, I left out 17 over 13. If you want to use that, that's fine. Any 2 that are consecutive. But we need to see if it's the same as we go left to right. And it's not, right? That's 5, and that's certainly not 5. So no. And another one. Is negative 12 over 48 the same as 3 over negative 12? Yeah. You get an R of negative 1/4, or you could write negative 0.25. Decimal or fraction in that case would be totally fine. Doesn't matter. Okay. First term, R, and minus 1. Okay, so far geometric, not difficult, right? Dylan, you be paying attention, taking notes. All right. Any questions on those, my dear? Okay. So kind of following the order of types of problems we did yesterday, find the indicated terms of the geometric sequence. So this says to find a sub 6 and a sub n for the geometric sequence. So understand, it's telling us that this is geometric. I don't need to do a test. I don't need to put a whole bunch of fractions together to make sure they're the same. If they're telling me it's a geometric sequence, all I need is to find the R. Oops, that's a negative 5. Sorry. So negative 15 over 3, or 75 over negative 15, R is negative 5. Okay? So they want a sub 6 and a sub n. This is just code for write the formula. Formula is a sub n equals. Okay, so that's what we're doing. It's just writing the explicit formula. First term times our R to the n minus 1. So that's a sub n. That's how you find a sub n. Meaning any term you want. You can plug anything in you want. And they want us to find the 6th term. So what do you think we do here, guys? Yes, that's right. I'll put the 6 with the n. Right, just like yesterday. I'm finding the 6th term. I plug in 6 for n. So 6 minus 1 is 5, right? And then I'm going to do negative 5 in parentheses in my calculator to the 5th power times 3. And the 6th term is negative 9,375. So there's a sub n and there's a sub 6. Good? Okay. This one is tricky. And there's none of these in the homework. And I don't know if you'll see something like this on the test at this point. It's way too early. But what I like about this problem is it really forces us to understand this formula. Okay? So think about how traditionally in the last 10 minutes we've been using this formula. we've been given the first term and the r, we find the r, and then we can make the formula, right, a sub n, or I can use it to find any other term. But that's not what they're giving us in this one. They're giving us a sub 4 and a sub 11. So I'm going to change this formula a little bit to match what I have. So what they want us to do is find r and a sub 1. I'm just going to let's just find r because it's enough work there. So I need to plug in, it's algebra. If I have to find r, that means every other variable in there has to have a value put into it, okay? So I'm going to adjust this formula a little bit. I'm going to call, so remember this, a sub n and a sub 1 are numbers in the sequence, okay? Where am I getting that from? Well, you know a sub 1 is, right? That's the first term. And a sub n, for example, a sub 6 is the sixth term. So these are actually terms in the sequence, one of these numbers, okay? So I'm going to adjust this formula to match this. Like, for example, I could make this a sub 11, because I have that. I could make this a sub 4 times r, which is what I'm trying to find, to the n minus 1, okay? Now watch. A sub 11 is 1/16. A sub 4 is -8. R is what I'm trying to find. Now what would n be? What would 11. Good. Because remember, n is 11. Usually we leave n blank because we don't have a number there, right? But we do in this situation. Now careful here. Mistake would be to put a 1. But that 1 usually comes from the fact, let's use this one, that 1 comes from this one. This one and this one are related. So what would this number be? 4. So we're taking the numbers we're given and plugging them in. And it's tricky, right? It would be easy to make mistakes, and we're still not done. We have to solve this wacky-looking equation and solve for r, okay? Like I said, I don't even know right now if it would be on a test. We would have a review, so we would be able to practice this, but let's continue on with it to just practice solving a weird-looking equation. So think of algebra. I have to isolate this r, okay? Now, I know that's 7. Fine, that's easy. And there's a -8 times r to the 7. So what do you think I would do first? Divide by -8, right? It's like if I had 10 equals -2x. How would I get the x by itself? I would divide by -2. Even if it was a squared here, who cares what the power is, right? I would have to get the -8 to the other side. Okay, so I'm going to divide those. Now, if you're unsure of whether to put the 1/16 in parentheses, just do it, okay? It's never going to hurt, but the truth is you don't need it on this one because the denominator is not a fraction or addition or subtraction or something. So your calculator knows to do that first, right? You're putting it in first, then divide by -8. But if you didn't know, put it in parentheses and then it doesn't hurt either, okay? So don't wonder about that. All right, I don't like that decimal. I'm going to hit math, enter, enter, and change it to a fraction. So I have -1 over 128 equals r to the 7. Now think about it. If I had, I'm going to make a real easy one. If I had this, or you probably would have seen this, what would I do to get x by itself? Square root, right? Well, guess what? There's something called a 7th root. Any root. You can put any number in a root. I can do anything I want to this equation, remember. This is mathematically correct. If I take the 7th root of r to the 7th, I'm just left with r. Just like if I take the square root of x squared, I'm left with just x. But, remember, I can do anything I want as long as I do it both sides. So I have to take the 7th root of -1 over 128. Here's a fun fact. You can take odd number roots of negative numbers. It's not imaginary. You can have negative numbers under a cube root, a 5th root, a 7th root, okay? Plus, if you weren't allowed to, our calculator wouldn't let us, and it's going to let us, okay? So I'm going to show you how to put this in. So if you remember under math, if you just hit your math button, there's a cube root there, and right below it, number 5 has an x root. That's where you can put in any root you want. But to do it, you have to put it on the screen first. So if I want the 7th root, I put 7, and then I go to math, and it's number 5. And if you look at your screen or my screen, it puts the 7 right in there, 7th root. And then negative 1 over 128, negative 1/2. R is negative 1/2. That's it. Or 0.5. Okay, so tricky. Lots of places you could easily make mistakes, but I really like how it kind of forces you to understand the connection between all the variables. Okay, but like I said, I didn't give you any like that. All right, 2-word problems and we're done. They're actually very easy, even though they don't look it. Anybody take chemistry? Yeah, you did. Did you guys do any half-lives of chemicals? Okay. Well, there are certain chemicals that decay over time. Like, for example, a half-life. If you have 100 milligrams of something, a half-life, depending on what it is, like every hour, it decays by a half. Like, it actually gets smaller and smaller and smaller. That's what this is talking about. So let me read. When a radioactive substance decays, so it's getting less, the amount remaining will form a geometric sequence. That's really important. They're telling us that what we are getting here is a geometric sequence. That means it has an R and all that stuff. When measured over constant intervals of time. The table shows the amount of an unknown substance initially and after 2 hours. So some type of radioactive substance, number of grams, they find it, let's say they find it, that's 0 before time has started. So they're calling that 0, okay? And then after 2 hours, that's how much is left. So you can see it's gone down. What they want us to find is the missing hours. How much after 1 hour, 3 hours, 4 hours, okay? It didn't ask for the formula or anything like that. This is when you're going to use your geometric mean formula. Remember I said whenever you're trying to find one that's in the middle of 2 numbers, you can use your geometric mean. It's a very nice formula. So to find the mean, we just do the square root of the product of those 2 numbers. And that will give us the one in the middle. So square root 1320 times 384. And we're going to get decimals, right? We're definitely going to get decimals in these real-world problems. And it said in the directions to round to the nearest gram, so that'd be 712. And always make sure your answer makes sense. I would know this was wrong if it was more than 1320, for example. It should be going down, and it should be more than 384, right? It should be in between those, so that looks pretty good. Now, we could create the formula and plug 3 and 4 in or whatever. Actually, this would be 4 and 5. I'll get to that. But it didn't ask for the formula. What can we do to find the other 2? Anybody know? If we only knew the R, that's what we're multiplying by each time. Remember? It's because the directions, or in the problem, it said it's a geometric sequence. So whether you do 712 over 1320 or 384 over 712, you're going to get the same number. It doesn't matter which 2 you use, but you will get the same number. So 712 divided by 1320 is this yucky 0.539. Okay? So that's my R, and I can multiply the 384 by that number. But here's where I'm going to start talking about the AP exam. And we're going to really talk about it second semester, but I want to start getting it in your head. When there's rounding involved, you always want to round as your final step, okay? So a problem like this would definitely be a graphing calculator problem. And you would not want to use 0.539. You would want to use the number on your screen because it's not rounded. It's exact. The brain of your calculator has the whole number. It doesn't stop at 4. It goes on forever. It's irrational. So what we can do is just leave it on our screen and multiply by 384, right? Just to get the next number. And we get 207. Makes sense. It's going down. And then to be really careful, I'm not going to round. I'm not going to use this number again. I want to get that big number on my screen again and multiply by 207. So usually someone will say, yeah, but I did it with the rounded number and I got the same answer. And you do. If I do 207 times 0.539 versus the whole thing, I do get 112. It's a little different though, 0.6, 0.5. And when does it cross over to 0.4 and 0.5? Do you know what I mean? Where it would round down or stay the same or go up. So I'm not going to risk it ever. I'm always going to reserve my rounding to the last step, especially since I have this nice calculator that I can see everything on the screen. So try to remember to do that. Okay? So understand you don't always need the formula. If you have the first two, you can just find the R and then just keep going. So that's what you're doing in the sequence. You don't have to have a formula and plug in. All right? Now, this question did not ask for us to write a formula. But if it did, we probably would have called this 0. We would probably have used this formula because it was already called 0. That would have affected the n because n is your term number. So when you're plugging in a number, even though this is 0, it counts as the first term. Remember, it got kind of tricky last test, too, with some of the years. Like, we start at 0, we start at 1. And the truth is, it doesn't matter. And I'm going to prove that to you in this one. But if you were using a formula here, you wouldn't have plugged in a 3. You would have plugged in a 4. Okay, so it's a little confusing. Let's talk about this one. You're offered a starting salary of $37,000. This is our last one. $37,500 for the first year with an annual increase of 5% each year. This means your salary will be 1.05 times what it was the first year. What would you expect to earn in your fifth year? So that's a typical idea. My salary goes up every year. Not by very much, but it does. Okay, so this was probably my first year salary. Now it's like $38,000. Just kidding, a little better than that. But you get the idea. So first thing I want you to take away from this is if you see a percent sign in a problem, you know it's geometric. Okay? Because, yeah, you're like, yeah, duh, this whole lesson's geometric. But remember, eventually everything's going to mix together. You're going to have to say, is it arithmetic or geometric? An arithmetic word problem would be you get another $1,000 that you're just adding 1,000 on. But when it's a percent, it's multiplication. That makes it geometric. And this 1.05 comes in with this. This is important. Listen, being a math teacher, if I go out to dinner with all my friends, except Ms. Shackton, they all think I can just do the tip off the top of my head really easily. Like, you're the math teacher, what's our tip? You know what I mean? So think about what you do when you figure out the tip. So let's just use a round number. If my bill is $50 and I'm going to pay 20%, I could do times 0.20, 20%, move your decimal point 2 places left, and my tip is $10. Okay? Easy. And I can easily say 50 plus 10 is 60 in my head. But a faster way to get to the total, especially if it's a weird number, would be 50 times 1.20. What that does is take 100%, so $50, and then adds in 20% more. So it goes straight to the total amount. Okay? So I wouldn't pay $10 as my bill. I'd pay $60 as my bill. It would be the total bill. So it's the same idea. If I just used 0.05 in the formula, it's only going to figure out what 5% of this is. I need to know what the total is plus the 5% put in there. That's a really common mistake students make. But if you always look at your answer and decide, does it make sense? I always will ask you to do that. Does my answer make sense? Am I going down the whole time? Did I make a mistake in there? They should be going down. In this case, if you use just 5% instead of 1.05, your answer would be less than what you started with. It wouldn't make sense. You wouldn't make less than your first year when they're adding 5% on each year. Okay? Same idea, one more thing I have to say, is if your amount is going down. So a really common question is like a car. If you buy a brand new car, let's say $10,000, okay? The minute you drive it off the lot, you change your mind. You're like, oh, no, I'm going to bring it back tomorrow. I'm not happy with it. I'm going to resell it back to them. You don't get your $10,000 back. Cars depreciate the minute you drive them off the lot, okay? So you would get less. Let's say you get 5% less. You would take that $10,000 and not use a negative number. You would do 100% minus, what did I say, 5%? So you would be getting back 95% of 10,000. So it's either you go above 100% because you're getting bigger, or you subtract from 100% if you're losing, decaying, going down. Okay? So I just want to talk about that. So let's go ahead and write the formula. We can find any year by starting with 37,500 times 1.05 to the n minus 1. Right? So I just called this a sub 1. It says first year. Nice and simple, right? Plug it in as the first year. And what year do they want to know? Okay, so in the 5th year, so 5 minus 1 is 4, 1.05 to the 4th power times 37,500. So my answer makes sense. In the 5th year, I would make 45,581. It didn't say what to round to, but it's money, so it's not going to tell you. So round to nearest cents. If I had forgotten to put the 1 on there, this would have been less than 37,000, like I said. So always look at your answer. So if you saw that, you'd be like, oh, I forgot to put in the 100%. You want the 37.5 plus 5%. Now, one last thing. Remember I told you about the G sub O? That formula, sometimes in these real-world problems, you're going to see it happen. They'll use this instead. You'll get the same answer, okay? So watch. If I did 37,500, if I called that year 0, my R would still be 1.05. But when you use that as 0, you take away the minus 1, okay? So there's no minus 1. What's confusing about this is n. When I call this year 1 and I want to know year 5, n is 5, right? N was 5 here. But in this situation, n isn't 5. That's what's confusing. So if a sub 0 is my first term, 2, 3 years, 4th year, this would be my 5th year on the job. So this is 1, 2, 3, 4, 5. But what number would I be plugging in to find this right here? Which is what we would, right? Didn't we do this to the 4th power when we subtracted 1? We did, right? What I put in my calculator was 1.05 to the 4th power. So that's how it changes. Either one is okay, you get the same answer, but it can be tricky here with your n. So when I get to choose, I like to use a sub 1, but we don't always get to choose. Okay, so I just wanted to point that out. Homework. Write that down, and then I'll do some maneuvering to make it all show up here nice and neat. Whenever I don't say even or odd, that means all. Thank you for listening. So you cannot sleep in the class. Well, I woke you up once. That's not my job, is to wake you up. So, okay, but that's not going to happen. Okay, it's also written on the board behind me. Uh-huh. So there's extras if you want to do more, but you don't need to. Oh, look, I forgot to tell you. Look at 19. That's a geometric mean problem. You can find the one in the dead center by finding the mean of those two. So those two multiplied together, square root, will give you the dead middle. Then you can do the mean of those two, and the mean of those two. If you get stuck on it, call me over and I'll help you. I'll tell you that in a minute. Um, 27. 27 is the last one. And I cannot fix it. But I will be putting it on canvas.